yeah, it was enough to break some records for most powerful homologated production engine in the world and the fastest production car in the world.
Elon Musk is accustomed to rivalry. However, he was not prepared for this at all. The computing world was completely taken aback as the millionaire genius broke down on live television, wiping away tears and letting out a voice crack as he revealed the shocking news that no one had anticipated. He was stepping down. And why? A brand new engine from Koenigsegg that is just stunning. Indeed, the legendary Swedish hypercar driver recently pulled off the unimaginable, and it sent shockwaves right through Tesla's defenses. The latest innovation from Koenigsegg isn't just another unusual engine, it's a revolution, an end to the game. Elon Musk is aware of this. The once untouchable Tesla empire is now facing its greatest danger to date, a machine so sophisticated that it even outperforms the Cybertruck. We're not referring to a glitzy trick or a small update. This engine challenges our preconceived notions about power, speed, and efficiency. Even lovers of Tesla are unable to speak. What's inside this enigmatic engine? What caused Elon to lose it the moment it was revealed? Stay tuned and watch till the end, because this isn't just about cars.
We never stop developing it because it gives enormous freedom to the combustion engine.
It's about a seismic shift in the future of transportation. Is Tesla's rule coming to an end? Or will Elon recover from his most poignant public appearance to date? Torque like thunder. Why 600 Newton meters changes the game. Despite its small size, Koenigsegg's TFG, tiny friendly giant, packs a powerful punch. The 2.0-liter inline-3 can operate in either 2- or 4-stroke mode when needed thanks to free valve technology, which uses electro-hydraulic pneumatic actuators to open each valve separately. An engine that weighs hardly more than a typical 4-cylinder can produce 600 horsepower and 600 Newton meters thanks to camless magic, ultra-high boost pressure, and an ethanol-friendly fuel system. The recipe is completed with a magnesium block, magnesium head, and an 8,500 RPM redline, which converts every ounce into output. The Gemera's TFG provides quick shove without lag because it has peak torque at low RPM. While on track, it maintains turbos spooled and throttle response razor sharp, while in daily driving, it translates to violent mid-range acceleration and effortless interstate passing. Simply put, more horizon-bending pull and less downshift seeking. The dark matter E-motor was the true surprise that Koenigsegg then revealed. With a weight of under 39 kilograms, 86 pounds, it generates an incredible 800 horsepower and 1,250 Newton meters, making it the most powerful-to-weight ratio of any automotive-grade electric motor available. 6-phase windings maintain a smooth current, and a massive 8,500 RPM ceiling is a perfect match for VTOL dreams or fast-paced road courses.
You'll see quite a resemblance, short overhangs, large air intake on the side, mid-engine, stowable, detachable hardtop, with a really integrated look so you get two cars in one, with fantastic performance.
Conventional E-motors take sides. Axial flux units want low RPM torque, whereas radial flux units seek peak power. The compromise was rejected by Koenigsegg. By combining both magnetic topologies, its patent-pending raxial flux structure allows flux lines to flow through the stator in two different directions. Without the need for a large reduction gearbox, the outcome is a record-breaking power density, a flatter torque curve, and less torque ripple. In a first for the industry, Koenigsegg uses carbon fiber to mold the motor's rotor, stator support, and exterior housing in place of stacked steel laminations. Carbon's thermal conductivity wicks heat away from copper windings more quickly than aluminum, its rigidity prevents deformation at 8,500 RPM, and its low density cuts mass. This is the ultimate material move for hypercars that are competing for every kilogram. By combining the 39-kilogram dark matter with the 600 Newton meters TFG, Gemera's hybrid system reduces weight by around 150 kilograms in comparison to its initial three-motor design. To attain the same 0 to 100 kilometers per hour burst, less weight implies smaller brakes, lighter suspension parts, and, most importantly, fewer kilowatt-hours of battery. The vicious circle of big battery, more weight, bigger battery is suddenly broken. Koenigsegg's 400-person skunkworks creates its wiring looms, gearboxes, inverters, engines, and battery modules. Christian von Koenigsegg's team is able to iterate at a speed that is unmatched by extensive worldwide supply chains, since they are able to keep R&D and prototyping under one roof.
So we have the 600 horsepower TFG 3-cylinder free-valve engine, combined with 600 Newton meters of torque, and we get augmentation by the 800 horsepower 1250 Newton meters dark matter e-motor.
Massive battery packs, software, and manufacturing scale were the foundations of Tesla's business. That thesis is directly attacked by Koenigsegg's featherweight hardware. Is the case for million-cell skateboard packs moot if a 4-seat hyper-hybrid can outperform EV flagships with a wallet-sized battery? It's no surprise that social media footage shows a visibly shaken Elon Musk grabbing for vague talking points. Which performance metric will reign supreme in the upcoming decade? Weight or watts? Raxial flux and 6-phase symphony. By substituting molded carbon fiber for every scrap of stamped steel in a traditional motor, Koenigsegg's engineers broke all the rules. The ultralight composite used for the rotor, stator cores, and even the outer shell reduces bulk to only 39 kilograms 86 pounds, while still allowing for 1,250 Newton meters of twist and 8,500 revolutions per minute. Carbon's rigidity maintains the magnetic air gap razor consistent for increased efficiency, while its low density reduces rotational inertia, allowing the motor to spin up faster and recover more energy under regen. Koenigsegg combined axial and radial geometries in a patent-pending Raxial stack in place of the typical 3-phase radial flux design. The team then divided the current between 2 separate 3-phase windings, doubling the number of phases to 6. The results are striking. The motor can produce 600 kilowatts continuously without reaching saturation.
Yeah, what have they done that is difficult and significant?
Thermal hotspots smooth out, and torque ripple virtually vanishes. In reality, this results in incredibly smooth throttle response and sprint times that, in contrast, make single-gear EVs feel jerky. David, a silicon carbide inverter that weighs only 15 kilograms, 33 pounds, but can generate 1,300 amperes root mean square at 850 volts, powers those 6 phases. With a box smaller than most rollerboard luggage that amounts to up to 750 kilowatts. Koenigsegg's engineers decreased thermal resistance and volume to 10 liters by milling the heatsink channels straight into the case and bolting the power modules directly onto a carbon backplane. For 1.5 megawatts,
no one else can do what we're doing. If you want that, you can't get it anywhere else.
A second similar unit can be ganged. Approximately 3 times the gravimetric punch of Tesla's Model S unit, the result is the highest power density automobile inverter ever recorded. Koenigsegg immerses the entire 850-volt pack in a dielectric oil containing nano additives, in contrast to most packs that adhere to cold plates beneath the cells. By slipping between each pouch and prismatic can, the fluid absorbs heat straight from the cell walls, allowing the chemistry to produce longer bursts with greater peak currents. The engineers were able to specify a lighter, smaller pack without compromising the duty cycle, which is essential when you're chasing every kilogram. Thermal deltas also drop, and cell aging decreases. That hardware isn't limited to a laboratory workstation.
We're talking about 800 horsepower and 1,250 Newton meters from one e-motor.
When in production, the Gemera connects Koenigsegg's twin-turbo 5.0-liter HV8 to an 800 horsepower dark matter motor, transferring power via a 9-clutch light-speed tourbillon transmission. With 4-wheel torque vectoring, a confirmed 2,300 horsepower system peak, and a curb weight hundreds of kilograms lighter than an all-battery competitor, the combination is powerful. Competitors could just label it unfair, but Koenigsegg refers to it as Tour Beyond Drive. The two pillars of Tesla's 10-year moat are its in-house battery size, with gigafactories producing 4,680 cells per gigawatt hour, and its all-electric story that captured the attention of investors. Even Musk's plan acknowledges scrap rates and ramp pains on new chemistries through 2026.
Never stop developing it because it gives enormous freedom.
But Koenigsegg is avoiding those economics by using a combustion aid and a smaller, high-performance pack. Dark matter shows that headline power and efficiency don't require the bulk of a skateboard pack, which is more concerning for Palo Alto. Tesla's batteries or bust approach immediately appears limited if the Swedish company licenses the technology or if other small-scale inventors choose the Raxial flux path. The focus of the EV wars may change from building the largest cell plant to maximizing output per kilogram of drivetrain. Licensing tsunami, Koenigsegg monetizes its motor inverter IP across mainstream OEMs, forcing a rapid pivot away from heavy three-phase units. Tesla counterstrike. Musk fast-tracks an axial flux program, he's hinted at it before, and leverages cell scale to undercut cost. Hybrid renaissance.
So we have the 600 horsepower TFG, 3-cylinder, free-valve engine, combined with 600 newton meters of torque. And we get augmentation by the 800 horsepower, 1,250 newton meters dark matter e-motor.
Regulators relax blanket electrification targets in favor of ultra-clean hybrids that match BEV efficiency without the battery burden. Gemera becomes the template. The resignation cascade. For the first time in years, Tesla's air of inevitable doom broke. Analysts were left wondering after Elon Musk hesitated on live television. How strong was the earthquake that was approaching Silicon Valley's crown gem if he could feel the ground shifting? Executives murmured the impossible in glass-walled boardrooms from Detroit to Tokyo. Had a Swedish hypercar company with 400 employees out-innovated the world's largest electric vehicle company? Quietly, the longtime CTO of Tesla submitted documents to explore new opportunities. 3 propulsion veterans followed in less than 72 hours, each of whom erased decades of motor design expertise. Farewell emoticons filled Slack channels, but the underlying message was harsh. Critical talent no longer thought Tesla had the best technology in the world. The outcome? A motor that is 30% more efficient, half as heavy, and, most importantly, scalable with next-generation automated layup. The EV strategy, which relied on ever-denser batteries, suddenly appeared susceptible to a lighter-is-faster paradigm. Musk didn't thunder when he eventually turned to the media. Instead, he thought, according to him, innovation is more like poker than chess. Sometimes you possess kings, and other times the river displays an ace. The stakes had just quadrupled, yet Tesla's wagers on battery vertical integration changed the course of history. With a cracking voice and uncommon humility, he suggested leaving his position as CEO and continuing to serve as the company's visionary-in-chief while new leadership develops Tesla 2.0. Exit stage left. Musk's sudden surrender. It was as if someone had turned off the electricity in the room when Elon Musk moved away from the microphone. Insiders sensed boardroom pressure, yet he talked about fresh perspectives. Before the markets reopened, a few directors wanted a fresh face after witnessing the stock chart plummet. Others were concerned about the impending gap between Koenigsegg's quantum leap technology and Tesla's incremental upgrades. Musk's departure was more of an emergency airlock maneuver to release the pressure and preserve the ship than a retreat. Christian von Koenigsegg welcomed a carefully selected group of doubters to Ängelholm when headlines were dominated by corporate drama in California. The dark matter motor came to life there with a soft, velvety hum instead of a mechanical whine. Its 15-inch by 5-inch size factor gave it the appearance of a luxury watch mechanism on a larger scale rather than a conventional drive unit. The shocker. Now, every gram that required iron shone in carbon fiber that was firmly knit. There is virtually no compromise, no eddy current drag, and no surplus heat. Koenigsegg reinvented motor physics, not just replacing steel. Because carbon fiber has a low electrical conductivity, it prevents eddy currents, which reduces heat loss and the need for bulky cooling jackets. Instantly, a material that is typically valued for body panels and monocoques was transformed into the core of propulsion, a feat of engineering that reduced weight while withstanding 20,000 RPM torture cycles without delamination. The analysts who had been honing their "Tesla lost its mojo" opinion pieces quickly revised them. After Musk's resignation turned into a tale of quick reinvention, shares began to rise again. On each brokerage note, however, there was a line that muttered, "Incremental, not revolutionary." Investors were aware that Tesla had addressed a problem rather than changing the rules. Koenigsegg's path, materials whiz, boutique innovation, and statistics so ridiculous they seem like mistakes. Tesla's journey, cost curves, gigafactories, and the unrelenting drive to lower the price of EVs relative to their gasoline-powered predecessors. Although they use routes as dissimilar as interstate and autobahn, both strive for the same goal: cleaner, faster, and lighter mobility. Koenigsegg's carbon fiber motor serves as evidence that exotic materials can withstand the daily duty cycles of drivers. That information won't be kept within Swedish walls for very long. In the meantime, Tesla's Gen 3 unit establishes a new standard for all volume manufacturers striving to meet cost per kilowatt targets. So, did Koenigsegg just sound the bell for the next round, or did he land a knockout? Will carbon fiber rotors become the new industry standard, or will Tesla's open patents pull the balance back toward Fremont? The goal of this race is to redraw the course entirely, not to see who reaches the finish line first. Now that a new era has begun, even Elon couldn't contain his tears. The game was completely altered by Koenigsegg. Remember to subscribe to our channel for more crazy updates. Will Tesla recover, or is this it? Tell us in the comments section below.